One more challenge that we saw in the original data was that some of the columns, they had actual text in it. Remember the gender, or saying male, female, and that's not really something that our model can use. So we'll now have a look at a transformation to make these variables usable by our model. There are two variables which have only this challenge on them, and that's embart and sex, that's gender here, and we're going to try and add them to our matrix of X, and you can see we have here already the variables that we could take straight away, as well as the age that we already fixed. That value, that empty value is fixed now. Next one up, how can we take the sex variable and instead of having male, female, female, instead of having a text here, have some numbers. And one good idea might be to have something like here, the survived status, where if the passenger died, we give a 0, and if the passenger survived, we give a 1. We could do the same here. So for male, we give a 0, for female a 1, or the other way around, doesn't really matter actually. And the convenient thing is, there is a pandas function to do exactly that. And by now you should really also get the picture why we really love using these libraries. It's an incredibly lazy way of doing things, right? Imagine you would have to do that by hand. Just in Excel, you would need to think about, what formula optimally to use. And these are compute optimal implementations already. So the libraries really make this beautiful here. So we simply use that pandas function, pandas.get_dummies, and then we use it on the column that we want to transform. So in this case, we said we wanted to do the training of the column sex. So we just picked this one column here inside. And then we use the pandas get dummies function on that single column. All right. What the pandas get dummies function will do is it actually returns 2 columns later. One of them I've already removed by just picking one of the columns. So it picks the one male and female columns, and I've just chosen the female column. I'll explain soon why. The female column, let's check it. It says 0. Okay, not female, that's true. 1, female. Next one is female, so it should be 1. Yes, indeed. All right, so that's correct. Now, why did I not use both of the columns, the male and female column that was returned? The reason is you should never have 2 columns which are always the same in their sum. If you look at this here, if the person is not female but is male, the sum is 1. If the person is female but not male, the sum is again 1. And this will always be true. If we use the pandas.getDummies function, we know is always going to be, the sum is always going to be 1, because for every string in here, we have 1 column that gets returned. So here we've got 2. And each of these columns will always have one of them to be 1. So the reason why you should never have a constant sum in these columns is it creates a situation that's called a singular regression matrix. Right? This sounds fancy, but what it really means is it creates some issues with your model's learning. It will have troubles converging. Some of the models, they will even throw an error and say, I don't even want to touch that matrix because it's singular. So easy way for the dummies variable where we know for sure the sum would be 1 we just pick one of them. And that's why we go here only with the female column. Let's do the same thing with the embarked. Embarked now has more different strings. Before we just had two, male and female. Here we can already see it's got at least three. It's got S, C, and Q as different variable realizations inside here. So these are places where people can embark, right, go onto the ship, and they're just abbreviated with letters for convenience. If we do the pandas.getDummies function again, this time on the column embarked of the data frame training, so only on this one column in other words, we will see that it returns three different columns. So an easy way to just drop one of the columns is the .drop function. So I'm using this on the data frame embarkations that I had created here. I'm saying embarkations is equal to this new dummy variable matrix that I had created. And using the drop function is the equivalent of what I had before when I was just picking one column. But it's, instead of just picking a certain column, it's actually removing one column, right? I would have had here the column C, Q, and S. And you see S is gone because I was using the drop function. It's important to say axis equals to 1. If the axis is 0, or not given actually, it would actually try and find S here, but as you can see, this is 0, 1, 2, 3, 4, and so forth. So there's no S, and it would throw an error. So that's why we have that axis, so it knows, I need to look on the horizontal axis of this object for the column S, and then drop it. Now we're again left with something that indicates whether someone boarded in C or Q, does not indicate whether someone boarded in S. And by the way, if you have only one or a very small subset dropped, it's no problem for the model, because S in a mathematical sense is also the absence of C and Q, right? So dropping that will not remove the information for your model.